In the previous lecture, we have discussed about the Ethernet implementation and some basic protocol prescribed by the IEEE and IEEE standards. See this summary table, whatever we have discussed in the previous lecture, that major characteristic was the media, in which length of the medium, and what are the line coding or what are the coding technique that support for the medium. Basically the implementation was four types of that we have discussed. This 10 base 5 is a kind of thick coaxial cable. Other was 10 base 2, a thin coaxial cable. 10 base T is untwisted, unsealed, uh, twisted pair cable. UTP means untwisted, unsealed twisted pair. It's no cover. Other was 10 base F. Basically, it is optical fiber. These two are in term of pair fiber cable. So we have discussed that these two was in term of pair of wires, and 10 base 5 and 10 base 2 are the single line. So you can easily think that a single line can support only for either transmission or for reception. So base 10, 10 base 5 and 10 base 2, these two implementation technique only support half duplex transmission or reception. Half duplex means either you can transmit or you can receive, but transmission or the reception either will happen only either transmission or the reception will happen at a time. No transmission and reception both simultaneously possible. But these two techniques, since these two have a pair of cable, so it can support transmission as well as reception at the same time. So this is called full duplex. So if you want to implement full duplex method for any node in the network, so you have to use 10 base T or 10 base F, and maximum length for the 10 base 5 is 500 meter, 10 base 2 is approx 200 meter, 10 base T is about 100 meter, and most highest length that can support is by using 10 base F, that is optical fiber, about 2 kilometers. And each of the implementation support Manchester line coding technique. This 10 means you can understand that 10 base 5 or 10 base 2 anything, this 10 represent, already discussed in the previous lecture, that maximum capacity or the maximum bit rate that can be supported, means 10 Mbps of data can be supported. One thing keep in mind here, that Manchester coding technique, in this subject we will not discuss different type of coding technique that are the subject of other concern. So but one thing keep in mind, Manchester coding maximum this type of coding technique can support up to 100 Mbps data maximum, not beyond that. But for the transmission of 100 Mbps, it requires 200 megabaud of bandwidth of the medium. So it means whenever you have to improve the transmission efficiency, or if you go further other technique which can support a larger data rate transmission, you cannot use this type of coding technique. We will discuss further in detail this type of discussion. So this was all about in the previous lecture. Today we see that how this standard developed for the next generation. 10 Mbps standard Ethernet has gone through several changes before moving to the higher data rate. Some of the standards or some of the protocols that has been improved, or some of the interconnection or internet networking technique that has also been evolved, so that the maximum or the data rate transmission can be improved. But in the uh, improving the network quality, one thing we should note, or we think we should keep in mind, that older version of the network should be compatible with the new version, or the extended version, or the improved version. At least some year, or the some. See, one very relevant example you can think, that your mobile handset can support 4G, 3G as well as 2G network, isn't it? 4G, most of the network today in today's life, everywhere 4G tower or 4G network is present. Still, your handset support 2G network, because in some time or in some where some place your handset will be useless. So that wherever technology improves, some of the previous techniques that also inherited in the improved techniques. So this is one of the important uh, parameter, or the important quality that we should, as an engineer, we should keep in mind. So to change the standard or to improve the techniques, major three networking techniques was evolved. One is bridged Ethernet. Suppose multiple number of nodes that have connected through a medium. Suppose 10 or 12 number of nodes are connected in a single cable. Means all of the nodes can transmit or receive only through the single wire. Now think the another situation. See the diagram. What the techniques? This technique what improves basically the increased capacity and the reduced collision. Bridge Ethernet, the use of bridge in the Ethernet network, that improves the capacity and reduces the collision. We will see here. Suppose a network have only one sender at a time, and the maximum rate that can support by the channel is 10 Mbps. See, maximum capacity 10 Mbps, and only one transmitter or the only one station has to transmit at a time. So there is a possibility, or there is certainly the one station can utilize the full available resource. So no need to distribute among other. Fully 10 Mbps can be utilized by that particular node. But suppose two station can transmit, or two station can want to receive, or at a same time two station starts working through this medium. So on an average we can say that maximum capacity is 10. So one node can transmit on an average 5 Mbps. So we can say, as the number of node increases in the channel through the medium, the maximum transmission capacity will be reduced by that factor. This is one important criteria. Keep in mind. Other, suppose this 1, 2, 3, 4, 5, 6 and 6, 12 number of nodes, these two from here to here, 12 stations are connected through a single wire, single medium. So if suppose two nodes, node 1 and this node 12, communicate with each other, it means the line medium will be busy at that time, and another station 6 want to communicate with any other 5 node. Suppose these two want to communicate. Earlier 1 and 12 was communicating, so simultaneously there will be the chance of collision. Means no other, when one transmitter is transmitting and another node is receiving, so at that time no other node can transmit or receive in this situation. But suppose this connection is modified like this: 6 nodes are connected through a single medium and 6 other are connected through the other medium, and both 6 are connected through this bridge network. In this scenario, you can see that when one station or the station 6, these two want to transmit, in this case no collision with the other signal when transmitted by the 7th or any other, suppose 11th. Means it is divided into two different network and two different network connected with a bridge. It means the effective utilization of this channel remains the 10 Mbps. Right side also the maximum transmission capacity remains the 10 Mbps. Still here effectively you can say the total maximum capacity through this link will be 1, 2, 3, 4, 5, 6, and one node is like this 6 all plus bridge. This is another considered as one node. If you assuming this is your main node, main network, so total you have only 7 nodes. Similarly, if you consider this as your main network, in that case again only 7 nodes are connected. Means you can say partitioning the network with 2 or more network and connect that through a bridge, which can improve the transmission capacity as well as reduce the collision probability. So this is one of the improvement that we can do in the network for the further improvement in the network. Next was switched Ethernet and full duplex Ethernet. In switched Ethernet, the bridge of this Ethernet connection, Ethernet network, is replaced by the switch. The major difference between this bridge and switch, you can see this in this diagram here. This is bridge only. See in this diagram what I was discussing. Later I will see. See here 6 and 6. Total 12 nodes are connected through a single cable. In this case, single cable is present, so only half duplex communication is possible through this connection, this type of connection. And collision probability will be high because larger number of node connected through a single medium. But when you reduce the length of the network or length of the each domain, you can say here only 3 nodes are connected in one domain, here also 3, total 12 nodes is divided into 4 domain and all connected through a bridge. In this case, suppose if this node communicate with this node, simultaneously this node can communicate with this node, or simultaneously this node can communicate with this node. At the same time, multiple number of communication can be possible without collision. But still here half duplex communication is possible because a single wire is connected through this node. So this is the major key point that you should keep in mind for bridge networking. Otherwise, switch network. In switch network, bridge is replaced by a switch. I was discussing that bridge and switch, a major difference between these two components is that switch have a larger number of port that can be connected through these domains. Larger number of port, but in bridge only 2 or 4 port will be available. So the bridge is applicable for smaller number of node is present over the smaller network. Switch, which can support for larger network or the large number of node is present. And other here aspect you should keep in mind that here also we use only half duplex communication because in this each domain uses either base 5 implementation. So here also collision will be very less as compared to technique. But the major advantage of switch that it can support full duplex. So why not this domain, each domain is replaced by a single node and each implementation, each channel of this network is replaced by twisted pair cable or optical fiber cable, so that simultaneously reception and simultaneously transmission can be possible, or we can say a full duplex network can be achieved. See in this diagram, similarly the switch have the capacity that it can support full duplex. So each domain is replaced by each single node and each single node is connected through a pair of cable, either base T or base F. Base T means twisted pair cable and base F means optical fiber cable. So in this type of scenario, basically this is improved version of switched Ethernet. Switch Ethernet improved version is full duplex because only what are the changes here, that only the wire or the medium that has been replaced. In this technique, since each node is connected through a pair of cable, so simultaneously it can transmit or it can receive, and each node is connected independently without any other effect of without affecting the other node, directly connected switch. So here collision is null. No collision will present. So the collision incident takes the this network. See, suppose this first node want to connect or to receive this 3. It can directly transmit at the same time. It can receive, and simultaneously this transmission and reception is taking place. Another node can also transmit and receive. Switch have the capacity to monitor or transmit or transfer the data from one node to another node at the same time for multiple number of nodes. So this is another kind of network implementation that modification has been done. Now this was basically the network standards in which we can improve so that capacity can be achieved and collision can be reduced. Further improvement in the data rate can also be achieved by some another technique, and those techniques are basically some improvement in MAC layer and some improvement in physical layer. MAC layer generally does not require any change to improve the data rate. In general, physical layer, basically only the change in physical layer can improve the data. How the physical layer implementation is changed? By changing the topology, by changing the implementation medium, by changing the coding technique. These are the methods that we can alter or we can improve so that overall transmission capacity or the fast Ethernet can be achieved. So major change in Ethernet is at physical layer only. The goal of the fast Ethernet can be summarized as this: upgraded up to 100 Mbps, make compatible with the standard Ethernet, keep the same, because this is at the MAC layer, so no need to change that MAC layer. 48-bit will be same as this. Keep the same frame format. Everything will be same as if you will see at the MAC level. But at the physical level, there will be some improvement which can be done and to improve the overall transmission capacity. The main consideration in the evolution of 10 to 100 Mbps was to keep the MAC save layer untouched. Same thing that already said. MAC layer, no need to change anything. And physical layer, the topology also affect the capacity of the channel. So 100 Mbps or the fast Ethernet network, if you have only 2 nodes are present, so in that case there will be a point-to-point connection and only a single pair of cable will give you the best performance. No need to put extra electronic component or extra network complexity. But when more than 2 stations are present, in that case all the nodes will be connected through a switch. In general, this is a type of star topology, already you know. So the fast Ethernet basically point to point as well as star. Star is used when more than two nodes are present. Only two nodes are present, that can be directly point to point connection, no need of switch. This is the type of topology. And what are the Ethernet implementation? Basically, what are the medium that support this 100 Mbps of speed? There are three major type of implementation. This is 100 base TX, which means two wire category 5 UTP. Two wire category means basically this is two pair of UTP. 100 base FS, two wire. This is also two pair of fiber. 100 base T4, this is four wire category. Here four pair of wires. This type of this is basically untwisted, unshielded twisted pair UTP. This is a fiber. This is also UTP. And for these base 100 base TX, 100 base FX, and 100 base T4, all these type of implementation, there will be a separate coding technique which support this type of method. This type of implementation does not support because it support smaller capacity, small bandwidth. So to achieve this maximum bandwidth, we have to choose some another coding technique. MLT coding is used for 100 base TX. NRZ coding and NRZ decoding are used for 100 base FX. 6B to 8B to 6T. This is another type of coding that used for 100 base T4. So different type of coding techniques are possible, but you should keep you should choose so that which type of coding can support which type of channel. That has been basically coding is not the part of this subject, so coding will be discussed in the other subject, digital communication subject, where you will see that what maximum bandwidth can be achieved by the different coding techniques. So I will leave here the different types of coding and their features. Only keep in mind that the channel 100T, 100 base TX, 100 base FX, and 100 base T4, all these type of channel can support different types of coding and decoding techniques. See the summary of fast Ethernet technique. Medium for 100 base TX is category 5 or STP. 100 base FX is a fiber, and 100 base T4 is a also this is same as TX, that is UTP. Number of wire for 100 base TX is 2, and number of test base and number of wire for 4, 2, 2, and 4. Maximum length of this TX is 100, 100 FX is also, and 100 base T4 Soft coding is while 4 to 4B plus 5B. Here also 4B plus 5B, and no specification is given for 100 base T4. The line coding technique is MLT and 8B60. MLT stands for, basically this is multi-level transmit. This is one type of line coding. Another is non to 0. 8B is 8 5 to 6 signal. Basically the name is 8 to 6. Basically this is a mathematical calculation. This converts basically 100 to 75. This is the concept. 100% to 75%. That's why here 6 to 8. 100 multiplied by 6 by 8. You will see this is 75%. That's why another technique. Basically this is compression of bandwidth. Up to maximum data can be compressed so that the higher data is put on the available bandwidth. So this is summary you keep in mind, and the note for this. Another type of Ethernet is Gigabit Ethernet. Gigabit means 1000 Mbps. Here also, to improve the network efficiency, the changes will have at MAC layer and physical layer, mainly physical layer only. And at physical layer, as already we have seen, that one improvement can be done by changing the topology. Another improvement can be done by the implementation of high transmission. Another coding technique that support the available bandwidth of channel. So this is major key technique or key point that you should keep in mind. Then you will not get confused. What are the implementation that use? What are the changes that can be done to improve the capacity of the Ethernet? IEEE committee the standard. IEEE committee has given the standard project 802.3Z for Gigabit Ethernet. This is a name given by the IEEE. The goal to achieve in this project is data rate of 1 Gbps. Rest, it is compatible with the standard and fast Ethernet. Previous version should be compatible with the next version. This is the key point. And rest 48 bit of source address and destination address. Same frame format that standard that uses standard Ethernet. Keep the same minimum and maximum frame length, that is 46 and 1500 type of is maximum and minimum bytes. This is the frame length. To support auto negotiation as defined in the first step. Everything will be same, only to change the physical layer. In full duplex mode of gigabit Ethernet, there is no collision. The maximum length of the cable is determined by the signal attenuation in the cable. One of the key points that you should not forget, that when you use a single wire between transmitter and receiver, this is half duplex. It means transmission and reception happen, but one will at one time. Transmission and reception of data is not possible same time. But when you use a pair of cable between transmitter and receiver, so here this is half duplex. This is called, this is called full duplex. In this, reception and transmission is at the same time. This advantage of full duplex technique can be utilized in gigabit. Earlier, see, in this technique, encoding and sorry, where in this I did one mistake here. Not two pair. This is one pair only. Two wire means one pair. One pair. One pair. Here two pair. All these one pair, one pair, one pair. This is replaced by two pair, two pair, two pair. For the gigabit, that is the major change. See here in the diagram. This is a one two pair. Here also two pair. Here also two pair. Here also two pair. The changes is done on the physical layer that implement. See one. This is the physically implementation of the channel. This is one technique. Another technique is change the topology. Point to point topology when only two nodes are available. When more than two nodes are available, that can be connected through the switch. That is star topology. Now more than three or more than five, six, seven. Similarly, that the another topology or the another star topology is improved in hierarchical nature. Hierarchy of the star can be implemented so that maximum data rate can be achieved. So this is one technique. A star connection and their hierarchy. This is important for gigabit Ethernet. And another is coding technique. Manchester code here also not supported. And another coding technique that utilized by this implementation is energetic feed. Pulse amplitude that can be supported by this channel. A comparison of gigabit Ethernet implementation for different channel is given here. Medium used is fiber of small length, short length for 100 base SX. Sorry, 1000 base SX. 1000 base LX will be the fiber of large width. 1000 base CX is shielded twisted pair, and 1000 base T is 5 category UTP. Number of wires is 2, 2, 2 and 4. Maximum length of respective implementation is 550 meter, 5000 meter, 25 meter and 100 meter. See, this summary table can be used for your some other type of objective question that you can think about. That according to this length, you can easily see that which type of implementation can be preferred for the smaller network, or the large network, or the directly you can say wide area network, or short uh, local area network LAN, smaller for the smaller geographical region, for the larger geographical region. Similarly, the maximum speed that can be achieved, what should be the population coding technique, and what should be the maximum channel behavior, types of channel that can be used for the different uh, implementation and network, and use uh, medium for the respective Ethernets, you can categorize their behavior and their application. So all this this is all about the Ethernet. So thank you. If you have any doubt, you can ask. If you do not have any doubt, so we will meet on the next lecture, next topic. Thank you.